Okay, good. Assalamualaikum and good afternoon. So we are from group that will present about the Large Hadron Collider. So me, Nur Aisyah binti Muhammad, and my partner, which is Nur Ilia Aizah binti Anwar, will present to you about the Large Hadron Collider. Okay, next slide. Why it is called a Large Hadron Collider? So for your information, this Large Hadron Collider is the largest cryogenic system in the world and the coldest place of Earth, which is it could reach a temperature uh, negative 273.1, which is equivalent to 1 Kelvin. So the LHC is the most powerful particle accelerator, and it's known as a large because its size, which is approximately 27 kilometer in circumference. So for your information, this LHC is located beneath the France and Switzerland border, and near to the Geneva. Okay, something like that lah. Okay, so next, it is called hadron because it accelerates particles, which is proton or ion, that known as a hadron. So as we know, hadron is a composed of quarks, which is we have a six groups of quarks: up, down, charm, strange, bottom, and top. Okay, so next, the we call it as collider because the particle will form a two beams that traveling in opposite direction and collide at the 4 points where the two ring of the machine intersects. So as we can see at the slide number 4, as you can see there is a 4 intersection points, which is has a CMS, ALICE, ATLAS, and LHC Beauty. So at this point, all the particles will what we call collide at this 4 intersection. Okay, so back to the third slide. So what is inside the LHC? So in LHC, it contains 7 experiments, which is known as ALICE, ATLAS, CMS, LHBC, and the other three, which is installed near it. So as the model, it will install near to the LHBC. The Large Hadron Collider forward is installed near to the Atlas, and for the totem, the total elastic and diffractive cross-section measurement is installed near a compact muon solenoid. So actually the main in the LHC is 4: ALICE, LHB, CMS, and ATLAS. Okay, slide number 2 please. Okay, so the LHC is built underground in the tunnel because actually the LHC is reused the tunnel that built for the Large Electron Positron Collider, but this LEP has dismantled in 2000. Okay, so the underground tunnel was used to build the next particle accelerator, which is known as LHC. Also, the underground tunnel was the best solution because it is way more cheaper to excavate a tunnel rather than to acquire the land that we need to cover in about 27 kilometer. Okay, so also that the earth crust itself provide a good shielding for radiation, and it also can minimum the impact on the landscape.
So I will explaining about the theory behind the LHC. Why was LHC created? So main reasons that it was created to increase our knowledge and understanding about our universe. So we can say that behind this machine, there are few theories to such as standard model and Higgs boson to understand about our universe structure and how it works, as well as proving the existence of subatomic particles. So the first one is the standard model. So in standard model, we have matter particles. So in matter particles, under the matter particles topic, there are like quarks and leptons, which are fundamental particles in the standard model, which all are half spin-like fermions. So there are 6 particles that pair up, which we call generations. So there will be 3 generations. So the first generation we call electron, and its partner neutrino. This is the most stable and lightest particles, while heavy and less stable particles belong to the second, muon and its partner neutrino. And third generations, it become more heavier and less stable, which is tau and its neutrino. So like leptons, quarks have 3 generations too. So first generation are up quark and down quark pairs. Second is the charm quark and strange quark pairs, and lastly top quark and bottom or beauty quark. So in standard model, there's also about forces particle. So as we know that we have our fundamental forces, there are 4 fundamental forces that act on matter particles, which is electromagnetism, weak nuclear force, strong nuclear force, and gravity. But in standard model, we might ignore the gravity because even though it has infinite range, but it's considered as weaker when we consider it with the standard model. So the 3 forces are known to be carried by exchange of force carrier particles that belong to a wider group named boson. So you can see in this image, this figure, the strong force is carried by gluon, while electromagnetic force is carried by photon, and W and Z bosons are responsible for the weak force. Meanwhile, gravity is carried by graviton. So the standard model explains how those forces act on the matter particles except for gravity because it is not a part of it. This model also combines elements from theory of relativity, which describe the microworlds, and quantum theory to describe the macro world. Standard models are proved to be the well-known physics theory to explain subatomic particles, but there are also some theories or questions that can be proven, such as Higgs boson, antimatter, or dark matter. So then we move on to the Higgs boson. So Higgs boson we actually particle that contributing to transfer the field, just like photons transfer the electromagnetic fields. So what kind of fields? We call it as Higgs field. So according to the Fermi National Accelerator Laboratory, 2050, the Higgs field is a force field that acts like a giant vat of molasses spray throughout the universe. So after the Big Bang, after the explosion, the whole space is filled with a non-zero expectation value of the Higgs field in the vacuum. So to know more about the Higgs field, how vacuum space is filled with Higgs field, we consider Mexican head-shaped potential, which is this equation. Micro is power of 2 is less than 0, and wavelength is more than 0. The maximum for potential is at the root. So around the circle where V is minimum, the vacuum will fix into one of the states, suggesting that the flux captures a non-zero value in the vacuum space. By then, the vacuum is filled with field. So as the Higgs fields grow and expands, unconsciously do the universe become cool and fall on temperature below the critical value. When particle interact with this field, it will increase mass. So when a particle is interact with the Higgs field, it will fill with mass, and more active it when it interact more actively, it will become the mass will be more increased. So basically, this theory is answer the questions about mass in matter. All this theory, we can find the solution behind it. So that's why LHC was built, because it's when the collision occurs, the matters, the path behind matters, we can make a research with the path that left behind by the explosion, by the matters, to find new discoveries. So that's all the theories behind the LHC machines. So in application, we have two types in application, which is proton smashing and the detectors. So basically, in how LHC works is quite interesting. When two beams of particles, such as protons, they will accelerate near the speed of light in two opposite directions and collide with each other. After collision, tiny particles inside the protons will split. So when they split, the path that left by the tiny particles, that's what we want. That's the scientists want. They will research it and make discovery by the path that left by the tiny particles. So we move to first proton smashing. So in proton smashing, we have linear accelerator 2, LINAC 2. We have proton cyclotron booster, PS booster, and proton cyclotron and super proton synchrotron. So these three machine is quite their function same. Their function is same. Like it will accelerate the particles, so that when the protons when they pass each of the machine, these three machine, they will accelerate increasing. Their speed will increase before went to the detectors to collide. So in this three machine, it will gain speed, and then when it enter to the detectors, it will collide. So let's move to the detectors. So in the detectors, we have four main detectors, which is toroidal LHC apparatus, ATLAS, compact muon solenoid, CMS, a large ion collider experiments, ALICE, and a large hadron collider, BEAUTY. So before that, we say that it gains speed to enter at the PS booster and whatsoever, but when it enters the detectors, the collision will happen. For example, in ATLAS, the collision of particles from LHC will occur at the center of the ATLAS, which cause shattering of near subatomic particles. So this is where the particles collide. So ATLAS function as a recorder to record the momentum, path, and energy of particles by using 6 different detective subsystems arranged in layers around the collision point. So in the tracker at its core, we'll gather the information that left behind the particles to keep it by ATLAS. So the data we receive by ATLAS. So next is CMS. In CMS, it also similar with ATLAS as a detector. Sorry, not CMS. Yes, CMS. To evaluate the subatomic particles that break away from collision. So it's kind of similar with the ATLAS. And next is large ion collider experiments, or we call ALICE. ALICE has to measure as many as possible escaping particles, totaling up to several tens of thousands in each of these little bands, and record their numbers, type, mass, energy, and direction in order to inform infer from to the debris the existence and properties of matters under the extreme condition created during the instance of collision. So simply to put, it just say that it's similar with Atlas. So it detects the particle after collision, and then it will helps to audit and repair the particle trajectories. And last one is LHCb, or Large Hadron Collider Beauty. So the main purpose is for a new machine is to study antimatters and matters. You will find slight difference between antimatters and matter by investigating the beauty quartz. It's quite different from the other detectors. So yeah, you will track the B quartz by the movable tracking detectors, and then they will gather the data, and the scientists will research the data. So that's all for application. Thank you.
As a conclusion, each component inside the LHC have their own different function but same aim, which is to investigate the universe and seek the evidence of theories proposed by a scientist. So thanks to LHC, the scientists are able to achieve a new evidence that helps them to work harder to prove that the theory behind universe making and matters. Okay, so that's all from us, and thank you so much.